Now, an example 2, a binary operation is defined by x delta y equal x plus y equal 2 base 9 on the set A 3, 4, 5, 6, 7. Yeah, so we need to construct a binary table for this. And now we need to take note, we are dealing in base 9, so our answer should be either 0, 1, 2, 3, 4, 5, 6, 7, 8, or a merge of any of these two values or any of these three values. The numbers, each digit you write here shouldn't exceed 9 or shouldn't be equal to 9. So that's the rule behind this. So we need a quotient and a remainder, in that order. So let's pick the first one. Let's say 3 delta 3. 3 delta 3. The rule is x plus y minus 2. So 3 plus 3 minus 2. That's 6 minus 2, which is 4. 4 can be seen here, so we can write 4. Let's look at 4 delta 5. 4 delta 5 becomes 4 plus 5 minus 2. 4 plus 5 is 9, 9 minus 2 is 7. So 4 delta 5 is 7. Let's look at 5 delta 6. 5 delta 6. That's 5 plus 6 minus 2. We have 11 minus 2. That's 9. Now you can't write 9 here, so you divide 9 by the base. So we have 9 over 9, that's 1 remainder 0. So 5 delta 6 is giving us 1 remainder 0. Let's look at 6 delta 7. 6 delta 7, that's 6 plus 7 minus 2. We have 13 minus 2, that's 11. Now we can't write 11, so we'll divide 11 by the base. So that's 11 divided by 9. 11 divided by 9, we have 1 remainder 2. So therefore 6 delta 7 is 1, 2. Now let's look at 7, 6. 7, 6. 7, 6. We have 7 plus 6 minus 2. It seems it's the same thing as that, because we get 13 here minus 2, and the answer will be 11. So just the same thing, that's 1 remainder 2. So 1, 2. So you can clearly see that the thing is commutative, because what we are getting for 6 delta 7 is the same as 7 delta 6. So you can clearly see that it is either symmetrical or commutative about the principal diagonal. So if you do it very well, if you do it very well, this is the result you are going to get. And you can clearly see that it is symmetrical, as I was saying, about the principal diagonal. When you draw a line through this, the value you get here is the same as the value you get here. What you have here is this 10 is the same as this 10, 8 here is the same as this 8, 7 here. So you can clearly see that it is symmetrical about the principal diagonal, and hence it is commutative. And hence, even this example can clearly tell that it is commutative. 6, 7 is giving us 1 remainder 2. 7, 6 is giving you 1 remainder 2. So it is commutative. Now let's look at the additional questions. 4 delta 4 delta 4. So we have 4 delta 4 delta 4. So 4 delta 4 delta 4. So first of all, look for 4 delta 4. 4 delta 4 is giving you 6. So we have 6 here. So 4 delta 6. 4 delta 6 is giving you 8. 4, 6 is giving you 8. So 4 delta 6 is giving you 8. Now the next example, which is the B part, which is 3 delta 6 delta 5 delta 4. Now 3 delta 6 is giving you 7, and 5 delta 4 is giving you 7. So 7 delta 7 is what? 7 delta 7 is 1 3. Now the next one, C, is n delta n equal 11. N delta n equal 11. So we look for two numbers that when they operate they give you 11. So let's check. We have 11 here, and this 11 is coming from 7 5, which we don't like. We are looking for two same numbers. We have another 11 here, which is coming from 6 6, and we have another 11 here, which is coming from 5 7. So the only 11 that is coming from the same number is 6 6. So 6 delta 6 is giving 11. So we can construct a truth set. N is such that n is equal to 6. Now the last problem, n delta 3. N delta 3 delta 6 is equal to 8. You are looking for a certain number n that when it operates on 3, you are going to get a result that when you operate on 6, you get 8. So you are going to identify 8 from the problem. So let's identify 8 in the problem. You have 8 here. So which means n delta 3. So you need n. So this 8. So when you put 3 delta 3, let's see. 3 delta 3 is giving you 4. And let's look at 4 delta. So this thing is coming from 7. This n is coming from 7. You want 6. Now this is 6. Now let's look at it. 4 delta 3. 4 delta 3. 4 delta 3 is 5. And let's see. 5 delta 6. 5 delta 6 is not 8. 5 delta 6 is 10. Which is not true. So we don't like 4. Now let's look at 3. 3 delta 3. 3 delta 3 is 4. And let's look at 4 delta 6. 4 delta 6 is 8. Yes, which is true. So 3 delta 3. So 3 delta 3 is 4. And 4 delta 6 is 8. 3 delta 3 is 4. And 4 delta 6 is 8. So you can construct our truth set. N is such that n is equal to 3. Yeah, so that is it. Now you can try your hands on these problems. Copy and complete this table. Some of the portions have been filled for you using this definition, 7mn minus m. And we have another few examples here. You have to operate this under this definition, 4a minus b, 4a minus b over b, 4a minus b over b in base 4. You have to evaluate 9 delta 3 and 8 delta 10 delta 5. And the third problem is you have to draw an addition table for base 5. For base 5 on the set K134. You have to state whether or not the operation is symmetrical or commutative.